Alright, so we're going to start with a biconditional statement. Alright, so think back like a geometry. So, two functions are inverses if and only if, right, IFF, if and only if f composed with g of x is equal to x and g composed with f of x is equal to x. So this is what this is saying. If I take x and I put it into function g and then I put it into function f and I get back to x that I started with, and if I take x and put it into f and then put it into function g and I get back to the x that I started with, then f and g are inverses of each other. And if that doesn't happen, then they're not inverses of each other. So here's an example. So if I ask you to prove or verify or show that f of x and g of x are inverses. That's when you're going to use the composite functions. So f of x is equal to 2/3 x plus 2. G of x is equal to 3/2 parentheses x minus 2. Alright, so I have to do two things. So first, I'm going to take f of g of x. So that means I'm going to take x, plug it into g, then I'm plugging g into f. Right? So that's 2/3 times 3/2 times x minus 2 plus 2. F is my main framework, right? And F says 2/3 times your input plus 2. But my input is now all of g of x. Okay, now I need to simplify according to my order of operations. So I'm going to work inside these parentheses first. That's going to be 2/3 times, I'm going to distribute this 3/2. That's 3/2 x minus 3 times 2 is 6 divided by 2 is 3 plus 2. Now I'm going to distribute the 2/3. 2/3 times 3/2, that's 1, so that's just x. 2/3 times -3 is negative. The 3's divide out 2 plus 2. Right? I distributed the 2/3. Now I'm going to come in here and combine. -2 plus 2 is 0. So I have x plus 0, which is x. Alright. Now, I need to do g of f of x. So now I'm plugging f of x into g. So my main function is g, but it says to take 3/2 times my input. Now all of this is my input. 2/3 x plus 2 minus 2. Three halves times my input minus 2. But my input is my g of x. Sorry, my input is my f of x. Alright, so now I need to work inside these parentheses first. So I'm just going to bring down my 3/2. 2/3 x plus 2 minus 2. I can add the 2 and the minus 2 together, and that would make 0. So now that's just 2/3 x. The plus 2 and the minus 2 added to 0. Now, 3/2 times 2/3, that's just x. What questions do you have? Yes.
Why is the minus 2 7?
Because it's coming from that one up there, and that's one's inside the parentheses. Alright, you ready to try this? Alright, so you're doing a proof, a verification. Alright, so now you're going to try these two. F of x is equal to 18 minus 3x. And g of x is equal to 6 minus x over 3. And your job is to prove or to verify that those are inversions. All right, talk with your team. Alright, let's take a look at these. Alright, so if you do f of g of x, you're going to take f as your framework, and you're plugging your g of x in for your input. You're going to distribute this 3, and you're going to get 18 minus 18 plus x, because a negative times a negative is a positive, and then 18 take away 18 is 0, and you get x. But when you do g composed of f of x, then you're going to take g as your main framework, and you're plugging your f of x as your input. And so the first thing you're going to do is divide, and so then you have 6 minus, and when you subtract, make sure you do parentheses. So it's 6 minus 18 divided by 3 is 6. Negative 3x divided by 3 is negative x. Then you distribute this negative 1, and you get 6 minus 6 plus x, and you get x. Okay?